In this third Word document, I will give you many examples of how to do signed two's complement, okay, how to work in unsigned numbers, and how to work in signed magnitude. Okay, so we work on the three cases. I'll start with the first example. You have 50 minus 20. In this case, you have a positive number, which is the 50, and you are subtracting it from another positive number, which is the 20. Okay, so here, anytime you have two positive numbers and you are subtracting them, okay, you can use either two's complement or sign magnitude. Okay, I will start with the 50. Okay, so how do you convert the 50? 50, it's going to be, this is your 50, it is 0, 1, 0, 0, 1, 1. If you want to double check your answer, this is 32 plus 16 plus 2, it will give you a 50. Now 20, it is minus, so as if you are doing A plus minus B, so you will have to get the 2's complement of the 20, okay, and this is the 2's complement of it. You add them, 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1, 1, and so on until we get here 0 plus a carry. We always discard the last carry when you are adding when you are subtracting two numbers. Okay, you always discard the carry, we ignore it. Now, what is the answer here? This is number 30, okay? And if you double check your answer, this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. You add them all up, they will give you a total of 30. How did I get a positive number? I am subtracting 50 minus 20. 50 is a bigger number, so when subtracting, of course, I expect to get a positive number, and this is the correct answer. Okay, any questions? Okay, I will do now 20 minus 50. 20 is a smaller number than 50, but again, be careful that I am doing the 2's complement and I'm always adding. So this is going to be 20 plus minus 50. So this is the 20 in binary representation, and this is the minus 50. How do I represent the minus 50? I write the 50 in 2's complement in binary, and then I keep going until I reach the first one, and then I complement the rest. Okay? Now I do the addition. Now that I have, this is 20 and this is minus 50 written in 2's complement, I add them, okay, and this will give me this answer. I want you now to look at the answer. It is 1 here. This means that this number is in negative representation, okay, it is in 2's complement. It is the correct answer, but to verify and to know what is the original value, I have to do 2's complement for it. So how do I do it? I keep going with until I reach the first one, so 0, 1, and then 1, 1, 1, 0, 0, 0. So this is my answer, and of course I put a minus before it, so this is minus 30. Okay, to verify my answer, look please, it is 20 minus 50, it will get me a minus 30. Clear? So these are two cases where A minus B, A is bigger, and this is A minus B where A is smaller. We did 2 examples. Any questions? Let me do now 20 plus 50, and I am adding. Okay, simply adding, I don't need the 2's complement. I convert the 20 into 8 bits, okay, which is 16 plus 4, it will give you a 20. And then I convert also the 50, okay, so this will give me the binary representation of the 20, the binary representation of the 50. I add them and I get this value. By looking at this value, I will see that this is a positive number. Converted to decimal, you are going to get a 70, which is the correct answer. In the exam, test 2, you will always be asked to verify your answer. So after you do the addition or the subtraction in binary, you will always have to verify your answer by converting it back to decimal. So you double check that you did the right calculation. Okay. We do now minus 20 minus 50. Now, this is the case where you have 2 negative numbers, okay? 2 negative numbers, of course you expect your answer to be negative. Unless the number exceeds 127, then you will have a wrong answer. Okay, you will have an overflow. Now, minus 20 minus 50 is equal to minus 70. So this is minus 20. I write the 20 in binary and then I find the 2's complement of it. Okay, so this is the 20 if you look at it. So you keep going until you reach the first one, 0, 0, 1, and then you complement the rest, 1, 0, 1, 1, 1. So this is minus 20. How about the 50? This is the 50. Now I want to write it in 2's complement. I keep going until I reach the first one, so 0, 1, and then I complement the rest. Fine. Add them now. It's a simple addition. I will get a carry. I always discard the last carry when I am adding in 2's complement. Okay, I look here at this number now. It is 1. This means that it is negative. So I put a minus here, okay, and I change the number 2 into 2's complement. So again, I keep going until I reach the first one and I complement the rest. And my answer is minus 70. Okay, any question?
Doctor, can you
repeat your question, please? You want me to repeat the last one?
Yes.
Okay, so this is 20 minus 20 minus 50. So the two numbers that you have here are negative. So you have to find the 20, find the 2's complement of it. You have to find the 50, find the 2's complement of it, and then add them. So as if you are adding minus 20 plus minus 50. You do the addition, and you will get here a carry. We always discard the last carry when we are working in 2's complement. So this is your answer. How do I verify my answer? Having a 1 here, it means it's a negative number, so I write minus here and I complement the answer. I keep going until I reach the first one, so 0, 1, and then I complement the rest. So 0, 1, and then I get the complement, okay? So this is minus 70. Okay, this is how you verify your answer. Adding two negative numbers must give you a negative number. In case it gave you a positive number, what is your answer?
overflow.
It is an overflow. Okay, is it clear?
دكتور نحن هون
Yes.
طيب الله اشتغل نحن هون على طول نشتغل ساين مش على ساين.
I can't hear you clearly. ما بعرف حدا. Anyone heard him? Please, can you repeat the question?
نحن هون على طول نشتغل ساين ما بنشتغل عن ساين هيك.
Yes, that's 2's complement, so it is also signed. Okay, so now you will see how do we do in signed magnitude. It's a it's a different way. This is in signed 2's complement. Okay, but you have to keep in mind that anytime you are adding two numbers, if one of them is negative, you will have to do it in signed 2's complement. Okay.
Thank you.
Any other question, guys?
دكتور نحن النمبر اللي تحت negative and positive من الوان
Yes, from the first of all, let me tell you, from the given that I ask you, it will be clear when I tell you the numbers are represented in 2's complement. So this must be clearly stated in the question. Okay. Let's say now I told you that the numbers are in 2's complement. What do you start to know if it is positive or negative? You look at the most significant bit. If it is 1, then this is a negative number. If it is 0, then this is a positive number. But I will have to tell you it is in signed 2's complement. You got me? It is binary. It is unsigned. It is signed. It is in signed 2's complement. So I have to tell you. Okay? It will be clear in the question. I keep going. Any other questions? Okay. Now I am doing two positive numbers. I want to add them and I expect to have a positive answer, right? So look what will happen here. I have 112 and 101. I convert them to binary, okay? And I got these answers. Now add them, I got this value. Knowing that the values are in signed 2's complement, what does this one tell you that you have here in the most significant bit? That this is a negative answer. But I was adding two positive numbers, so I'm expecting to have a positive answer. Because I got a negative answer, this is an overflow. But how would you really explain this overflow? Why did I have it? Why did an overflow occur in this case of calculation? Anyone, guys?
112 equal number bigger than 7.
When you add them up, yes, of course, the number exceeded 127. Okay, it is 213. So the number exceeded plus 127. So yes, this will give you an overflow. Okay? So this is why I got an overflow. But how is the overflow proven in the calculation? When the most significant bit is a negative number, knowing that I am adding two positive numbers. Okay? So this is the case of an overflow. Another case of an overflow is this. Who can help please with the explanation? Okay, what?
تو negative أعطونا positive.
Yes.
حياة
Yes, correct. But help me with the steps. I get minus 101. I write it in 2's complement. I have minus 112. I write it in 2's complement. So I am expecting to get an answer of a negative answer. Adding them all up, I got a positive number. Of course, I discard the carry in 2's complement. I got a positive number. Where did this positive number come from? Because I have a number that exceeded plus 127. Okay? I have to repeat that working in 8 bits, the biggest number that you could represent in 8 bits is plus 127 and minus 127. Other than that, the answer will be an overflow. Clear? I keep going, or you have any questions? Okay. So we continue now. I am working on sign magnitude. What do you remember, please, about sign magnitude? Sign magnitude, what is it, please?
We have a bit for the sign and the others are representative of the magnitude يعني البت يعني ال number بلا ال sign.
So 1 bit less sign and the 7 bits are for the magnitude, right? Correct. Okay. So you leave the binary representation as it is. You don't change anything. You don't do the complement. You don't do 2's complement, nothing. You leave it as it is. We only change the sign. Okay. So the number 101 is this. Okay. So no, sorry. I'm doing sign magnitude. Okay. So the number 20, this 20, is the same whether I have a plus 20 or a negative 20. What will differ is the sign. 0 will mean plus 20, 1 will mean minus 20. Clear? So this is for the sign magnitude. I want you to notice, please, that when you are working on sign magnitude, and I put it here as a remark for you in red, in sign magnitude, adding two opposite numbers cannot be done. They either have to be two positive numbers or to have to be two negative numbers. Anything else, you must use sign 2's complement. You got this idea? So you cannot add one positive number to a negative number. Okay, they must be either two positive or two negative. So be careful. Okay, so you have plus 20, plus 50. So I'm expecting an answer of a 70. Look, please, this is 20 and a plus. So 7 bits are used for the magnitude and 1 bit for the sign. Now this is the 50. I have 7 bits for the magnitude and 1 bit for the sign. I don't include the most significant bit in the calculation. So it is 0, 0. I automatically write 0. I don't include it in the calculation. So if I'm going to have a carry between this and this, it's going to be written here, not added to the sign. You got the idea? So we do the addition and I get this number. Question, is this number positive or negative? I have a 1 here. What do you think? Yes, guys? Is this a positive number or a negative number? This is a positive number
Positive.
because this sign, this number is the sign. Not this, not the most significant bit, this. Okay? This, the 8th bit here is the sign. The most significant bit is the sign. Okay, guys? Okay, so this is, of course, plus 70. Why I did not get an overflow? What do you think? Why?
Because the sign stays the same.
The sign is still the same is one answer, and another answer is the number did not exceed 127. Okay? Clear? the number, the total is 70. So it still can fit in 7 bits. This is the idea. We move to minus 20, minus 50, minus 20. Yes, what are we doing here? I am adding two negative numbers. Okay, so this is the 20. I just put a 1 here to designate the sign. And this is this is the 50. This is the 20 here, and I put a 1 for the sign. Look, please, 1, 1. I directly write a 1. I am not adding, so you don't put 0, carry on. You got the idea? Okay, I don't want this to be ambiguous to you. When you are working in sign magnitude, 0, 0, you write a 0, 1, 1, you write a 1. It's a sign. Nothing to do with the addition. Okay, you just write the sign. And here you do the addition. Okay, so here you add. Clear, guys? Did I get an overflow?
No.
Again, why?
لأن النمبر did not exceed 127 وزيت الساين بعده مثل ما هو.
Very good. So this is the only case where I can use sign magnitude. I have two positive numbers or I have two negative numbers. Let me show you how do you get an overflow in sign magnitude. I am adding 84 plus 82. So this is 82. I write it as it is. I don't change anything in it. Okay. So this is the representation of the 82. Okay. And this is the of 84, sorry. And this is the representation of 82. And I put 0 here because it's plus 84 and 0 here because it is plus 82. Adding them here, 0 and 0, I directly write as 0. Okay, add them up, you will have a carry here. Do you see this carry? This carry tells me that I have an overflow. Okay, because the carry that you have, it must be before the sign. So your sign is the most significant bit. The carry before that will give you an overflow. Okay, clear?
Yes.
Sharbil, is it clear?
Yes.
طيب. How about here? Can you explain what happened here? Minus 82, minus 84. Yes? You have 7 bits for the 82 and 7 bits for the 84. And you have here the sign 1, 1. I automatically write 1 here. And then I add them. It will give me a carry. Having a carry will mean it's an overflow. Notice also that the number is 166, so it exceeded 127. So yes, I have an overflow. Yes, guys? Any question? Okay. Now I am working with unsigned numbers. Unsigned, it means that I am using the 8 bits to represent my number, so not 7 bits. So I can reach up to 255. When do you think I get an overflow in the case of unsigned numbers? What do you think?
When the answer exceeds 255.
Very good, very good. When the answer exceeds 255, you will get an overflow, okay? And if I am adding two unsigned numbers, it is a simple addition. What if I am subtracting two unsigned numbers? What should I do? Subtracting two unsigned numbers. What should I do?
Smaller than minus 255.
We check which one is greater.
You don't have to. You don't have to really. You could get a negative answer, no problem. So what is it? We need to use 2's complement when I have a subtraction. You got the idea? If you are adding, no problem. You are doing a plus b. But what if I'm doing a minus b? Even if a, b are unsigned, you still have to use the minus to subtract. And I will have to go again use the 2's complement to work on it. Okay? Let's do unsigned numbers now. You have 84 plus 210, and it's equal to 70. Notice, please. First thing, 80 is written in binary. And this is number 210. This is unsigned. So the one that you are seeing here does not designate the minus. It's a number. So I'm using the full 8 bits for it. I add them and I get here an overflow. Why? Because the number exceeded 8 bits. Here you cannot discard the carry. Okay, here the number exceeded 8 bits and the answer is actually 294. It's greater than 255, so overflow. Okay, notice that it gave you 70. When it gives you 70 and it is supposed to give you 294 because there is a mistake, right? Mistake is, the cause of this mistake is the overflow because it's exceeded 255. Okay, guys? That's another example. I am doing 50 minus 20. 50 is unsigned, 20 is unsigned. Okay. But you have to subtract them. When you have to subtract them, you will have to go again to the 2's complement to do it. Okay, because how can you subtract two numbers? So you do 50 in binary, and 20, you write the 2's complement of it, and then you add them. In this case, you will have to discard the last carry because again we are here in 2's complement. Okay, clear? Any question? Okay.
Doctor,
Yes.
why do we use signed numbers انه اذا فينا نستعمل قصدي السايند ماجنتيود سيستم ليه نستعمله اذا فينا نستعمل هذا الكومبلمنت توز كومبلمنت للسبستراكشن.
These are ways of representation. You either represent them in sign magnitude or in 2's complement. They have two ways of representation. So I have to teach you the two methods or the two representations. Okay? You have sign magnitude and 2's complement. We have two representations. You have to know the two. Okay, but there is a limit for the sign magnitude. You cannot use it if you are subtracting. You could only use it if you are adding two negative or adding two positive. That's the limit in sign magnitude. Okay, 2's complement you can. Okay, so check now the 50 minus 20. 50 is larger, so you are expecting a positive number. Okay, how about if you are doing 20 minus 50? 20 minus 50, of course, the 50 is larger, so you are expecting now a negative answer. I want you to know what happened here, please. What did I do in this exercise? Yes, Carmen, can you try? What did I do in this exercise?
حولنا ل 2's complement 9 minus 50.
The 50, right? And the 20 is in binary. Okay, so this is negative 2's complement, and this is the,
Yes.
because it's positive, you add them. What can you tell me about this addition result? Is there an overflow?
No.
No, there is no overflow. Is it positive or negative? The answer.
Negative. لأنه the last bit هي 1.
Because the most significant bit is a 1, this number is negative. Okay.
Yeah.
Is this answer that you got here, is it true or you have to do anything for it? Is this the final answer?
No, we need to remove the one that indicated that the number is negative.
But I have to say that this is the answer. This is the answer, correct. I only do the conversion. This is what I'm trying to clarify. I only do this conversion to verify my answer only. But this is the answer. So what you will get from the CPU and doing this arithmetic will be this. But we change it back to 2's complement only to verify our answers. But the answer that we got is the answer from the CPU, and this is what we should expect. Okay? Clear? Yes, please. Any question? So these are all the examples. I put them for you in one Word document. It is on Blackboard to clarify all the cases. So now whatever you get in the assignment or in the exam, you will know how to solve. Okay? Any question before I move to something else?
All clear, thank you.
Okay. What I will be doing now is I want to explain for you Logisim. Okay? Did anyone install? Did you download it?
Yes.
Okay. Any
Yes, doctor.
difficulty?
No.
It needs Java.
Oh.
It needs Java.
Yeah, أنا نزلت جافا كمان.
Did you
Yes.
update it? You already have Java, no?
أنا نزلتها بس ترى
no.
هو.
What we will be doing now is I'll explain Logism program. This will help you to draw or to create your combination circuit on Logism, and then you will verify the output to check if the output is right. So I will start with the content. First, we will explain the Logism interface, definition, why do we use it for, the features, and we start. It might look a bit different from the version that you downloaded, okay? Because now they have the version 2.7, but it doesn't matter. The idea is the same. I will start explaining now here with the Logism what you have. Here you have the and, the or, and the not. So easily you drag to the canvas and you start drawing, okay? Let's say you want to do A, B, C. A, B, C, it is you have an A, you have a B, you have a C, and you need an AND gate, and you get an output out of them, okay? So this is how you start creating the gates, okay? Logism is an educational tool for designing and simulating digital logic circuits. It is a very simple toolbar interface. You will be able to simulate the circuit. When I say simulate, you will have to do on a paper the truth table, the K-maps. You will have to find the logic expression of it, the Boolean expressions. And after you do that, you draw it on a piece of paper, the logic diagram. Now is the time to use the Logism. So all the features from the steps from 1 till 4, they have to be done on a paper. And now that you have a logic diagram ready for you to use, you draw it on a Logism. Yes, please.
بما اني ايش اشياء سكرين ما ارجع عندي اشياء سكرين او شيء.
You need it, doctor. I can't view what you're talking about.
Okay, so I will repeat. Now you can see, right?
بعد لودينج بس.
No?
اي هلا انا بشرح لك.
هلا we can see.
So this is
Hello,
what I was
thank
telling you.
you.
Okay, I will repeat. I didn't know you were not seeing the screen. Okay, so I will repeat now. This is the AND, this is the OR, this is the NOT gate. You drag them here and you insert you draw your circuit, okay? I was explaining here that after you do the truth table, the K-maps, you find the Boolean expression optimized, of course. You draw the logic diagram on a paper, and now you want to copy that logic diagram to the Logism. Okay, so this is how we will be doing the project. I will give an example, okay, or a specification of a circuit, and you do all the steps, and once it becomes a logic diagram, you move to the Logism only to simulate, okay? So, of course, it is a very simple interface, not that difficult. You can build larger circuits from it, okay, from smaller sub-circuits, and the gates, whether simple, the AND or not, or the complex gates, the XOR, the NOR, the NAND, are all available. You just drag and use, okay? Make sure when you are downloading Logism to download its libraries also, because the libraries, they will have in them multiplexers, decoders, arithmetic logic unit, so they will have more blocks for you to use, okay? Logism can be used to design and simulate an entire CPU for educational purposes. It can do an adder, a subtractor, a complementer, a multiplier, so all could be done using Logism, okay? You have already blocks available, you just use them, okay? Now, students at colleges and universities around the world will use Logism for a variety of purposes. The main reason behind it is the simulation, okay? You have a module in general education computer science survey. It could be a unit in a sophomore level computer organization or a full semester. Of course, we will only use it as an example for simulation, okay? I will not be using it throughout the semester. I will only give you 1 or 2 projects on it just to try how do we simulate using a software, okay? It is free, Logism. It is open source, so people can add to it. It runs on any machine, so you could have it, but you need the Java. Of course, now not Java 5 later, because this is an older version. You said now that you downloaded 2.7, right? So you will need a newer, later version of Java, okay? It works on Mac, OS X, or Windows. So if you have any of these, make sure you specify the Windows type or the operating system if you have Mac OS, and it will be downloaded. The drawing interface is based on an intuitive toolbar. It is very simple to learn. And the wiring tool, now, it draws horizontal and vertical wires. If you are connecting the output of an AND gate to an input of an OR gate, you will need to use the wire, okay? Completed circuits can be saved in a file. So please, when you finish your drawing, I want you to save the file. It's going to be with extension .circ, so CIRC. So when you want to submit to Blackboard, I want the circ file and the Word file that you created for the project, okay? So I want the two files. It's not enough only to give me the Word file. I want also the circuit that you created, okay? Circuit layouts can be used as subcircuit. So you could use the circuit, let's say, that you created now as part of another circuit. We call it a subcircuit. Okay, it includes circuit components like you could use, they already have a RAM, they already have arithmetic circuits, they have multiplexers that you could use. The included combinational analysis module allows for conversion between circuits. It also shows you the truth table and the Boolean expressions. So here we will have to work as a first project. It's going to be a simple combination circuit. I already posted it on Blackboard, so you can anytime start working on it. Okay, and then when we finish and we advance more in the course, I will ask you to do another project, okay? So we start now. You have two variables, x, y, and the gate that you have here is a XOR gate. Or if you want to use with the simple gates, it's going to be, of course, x bar y plus xy bar. So you have two AND gates like you see here. Let me change to a pointer. So you have here this gate, it's an AND gate. So this is x bar y, x, y bar. So this is an AND NOT gate for the x, NOT gate for the y. This is an AND gate for x bar y. This is another AND gate for x, y bar. The output of this, using the wiring tool, should be connected to an OR gate. And this is the output of this AND gate, the input of the OR gate. And this will give me the output of XOR. Any difficulty, please? So you simply drag, you drag a wire or you write on top of it X. You can write on the wires, okay, to name them. And then you drag a knot, and then you connect this wire, you drag the and you connect this wire to this. So now the AND has two inputs, okay? When you drag an AND gate, it will show you more than one input. So if you have two, that's it, okay? But of course you can have three, you can have four. Now this is another AND gate you drag and you put in the canvas, and then you connect to it X and Y bar. And now you drag an OR, and the output of this, you drag a wire to connect it here and another wire to connect here, and you write the name of the output. Okay, it is not difficult, but the main thing is to have a circuit that is already working, then you draw it on the Logisim. Okay? We call this now, we just drew, we did not do any simulation. I'll show you now how to simulate. So first of all, orient yourself by adding gates, adding wires, adding text, and then testing your circuit. We reached now step 5. Can you read, please? Is there any difficulty until step 5? I'll show you now how to do it. Okay? Any question? Okay. So check this, please. This is how when you start your Logisim, you will have a similar window. So this is your canvas, and these are the gates that you drag and put here, okay? You should see the symbol, which is like a hand, okay? The hand is to poke. What does poke mean? You start by poke. When you click on the wire X, it's going to be the input 0, okay? And when you click on poke, the 0 input will change to a 1. So now, let's say you are giving input to the circuit 0, 0, 1, 1. What do? X will have a 0, Y will have a 0, Z will have a 1, W will have a 1. You got me? So these are now 4 inputs, and you click on the poke on the wire, so you change the input. Okay, so notice please. This is an AND gate, and it has these inputs. So when you click, after you select them, okay, when you click on the wire, you poke, and poke, okay, and poke will change the input from 0 to 1. So now every change in the input will give you a different output. You agree? Joe, are you following?
Yes, I am listening.
Okay, do you agree that when you change the input, you will get a different output?
Yes.
Okay, how am I going to check that you got a different output? Look what you have to do. You need to do screenshot, you print screen. Okay, so I want you to change the input 4 times, and you take 4 screenshots of your output, and you copy them to your Word file that you will submit to Blackboard. You got me? So I want you to change the input 4 times. So you get different outputs, and you double check that you have the right output. You do print screen 4 times, and you paste them in your Word file. Is this clear?
Yes.
Okay, good. So check this,
دكتور
please.
بالوورد فايل بس شو نحط على القد؟
In the Word file, you will have to put the truth table. You will have to draw the K-maps, write the Boolean expressions, and then when you finish the circuit on Logisim, you take a screenshot of it. And then, as I said now, you change the input, you will get 4. Every time you change input, you will get an output, right? It will be different.
Correct.
I want 4 screenshots of 4 different outputs, so I know that you simulated the circuit. Okay?
Okay.
Clear?
Thank you.
Okay, so check please now. This is the not, this is the not, and, or. You see, I put all the circuits that I need, and I need now to connect them with a wire from here to here, with a wire from here to here. You see how we do it? And then the output of this will be connected here, and the output of this will be connected here. Okay? Now, when I click on this poke, this will change the input. Okay? So notice please now, this has a 0, this has a 0. What is the output of the XOR gate if I have 0, 0 as input? What do you think?
0.
0. Why? Because XOR is for mutually exclusive. X and Y must be different, so I get an output of 1, right? So now, if I click on this with the poke, I click on this, what will happen? It will become
1.
1. So automatically having a 0 and a 1 will change my output. Do you agree? Yes?
Yes.
What will the output become? It will become 1. So now you take a screenshot. So I will have 4 screenshots of different input. And of course, they will give me different output. You got the idea? Okay, so this is how you
Yes.
will be working in the assignment. See? Now this is another step where you get the wires. After you have all the components blocked out on the canvas, now you are ready to start adding wires. Adding wires is the most important part because you are actually connecting all the gates in your circuit. Okay? If by any chance you connected something wrong, of course you will get a wrong output. So this is why I need to see 4 screenshots to double check that you are having the right output in your circuit. Okay? Notice please now, I finished adding the wires. As you draw wires, you may see some blue and gray wires. Now, what is the difference in the colors of wires that you are seeing? Okay, so you have to be careful with the wires because each color tells you a different thing. Okay, I start with the wires. So notice. How do you test your circuit? I just told you. 0, 0 will give you an output of a 0, right? Now poke this here, it will give you 1, 0. Poke here, it will give you 1, 1. You got the idea? And you will see different outputs in every case. Every time you poke the input, you are going to have a different output. Okay? So now, testing your circuit. How do you test your circuit? Now, to try another combination, look what he did. He poked the 0. So now I have a 0 and a 1, and it gave me a 1. Do you notice how these colors go? So this is a 1. This is going to be here a 1. and this will be converted also to a 1, so it's an AND. So you see the flow of it until it reaches here a 1. Okay? Clear? Okay, now what is a subcircuit? Subcircuit is when you create a small circuit. When you create a small circuit, let's say you create a XOR, and then you use it to create remember the example we gave in class, like the 3-odd function that needs 2 XOR, okay? And then you want to create a 9, okay? You have 9 XOR. So you create a small subcircuit and you use it to create a bigger circuit. This is the main idea of using subcircuits, okay? You can create subcircuits for NOR, for XOR, for a mux, for 4-to-1 mux, and we will learn how to use these also on Logism, okay? So you have the file menu, so you save your file, you save as. The file extension is .circ. You could edit the menu if you have to copy paste. You can create a project if you want out of your circuit, because if you have more than one circuit and later you want to combine them to create a full circuit, so sub-circuits, and you want to create later a bigger circuit or a bigger block out of smaller blocks. Simulate menu, this is how you do simulation. Of course, help will give you steps of how to do it. And the window menu will, if you want to create more, the window you have 3. The one for the gates, the one for the attribute, and the one for the canvas. Okay, so notice please here now, you have, but here you have to download the library. If you don't download the library, you won't have all these components. Make sure you download the library with it, okay? We have the NOT gate, the buffer, remember the buffer, tri-state buffer. You have the AND, the OR, the NAND, the NOR. You have also the XNOR. You have the odd parity. And these are later if you want to create a MUX or an ALU or a decoder, all of these could be created, but you have to download the libraries for it, okay? I continue with this. So you have built-in libraries, okay, that you have to download, as I said, while you are downloading the Logism. You have the Logism libraries, all of these, and now, of course, we have additional libraries that you could have seen yesterday while you are downloading. Okay, so they are libraries that are distributed with the Logism. We call them built-in, okay? Number 2, Logism libraries, they are projects built within Logism and saved to the disk. You can develop a set of circuits for you, and then you use them to create a bigger project, okay? Like you can create XOR, and then you could use it in another project, okay? You have other types of libraries also that are developed in Java, okay? So, but they are not distributed with Logism. You can download the JAR libraries, what others have written. So someone else have written something you can download and you could use, or you can write your own and someone else can use, okay? So check this please. I went over these, but I'll quickly repeat quickly. That's poke. This is to select. This is for the wiring. This is to write text like X, Y, A, B, X, XOR. You write the output. The splitter is good if you want to split one wire into 3. We use a splitter, okay? So here later we will use these if you want to add a clock. We did not add clock by now. We will add them in sequential circuits, okay? So memory libraries are the register, the RAM, the ROM, the flip-flops. We will learn these later in the course, okay? Of course, here we have the multiplexers, the decoder. We have the adder, that's for the ALU. Adder, subtractor, divider, negator, comparator, all of these are already available, arithmetic that you could use, okay? This is when you are creating the table, okay, and we said that you will have to simulate. I will repeat the idea that I want you please to take 4 screenshots for me. Every time you change the input, take a screenshot, okay? Notice please the splitter. You have 3, you can join them into 1. So this is now 1, 1, 0, and you can split again and each bit will go to a separate line. So this is called a splitter, okay? I'll explain wire colors now. Wire colors, you have the output that you are seeing. So 0, this color. 1 is this color. So now you see if 1 is passing through the circuit, you will see the dark the light green color, okay? What if you have this? I want you to be careful. If you have a red wire, there's something wrong. You have to eliminate. Do not submit to me a circuit with a red wire. There is something wrong, okay? So gray, the wire width is unknown because we do not have if it is 1 bit or 4 bits. Okay, the blue, the wire is for carrying 1 bit value. So if you have a 1 bit value, it's going to be blue. The dark green, it is holding a 0. The light green, it's holding a 1. The black, the wire is carrying multiple value. Yani you have 1, 1, 0, so 3 bits. It's going to be a thick wire and in black. The red is going, you have an error. So be careful to eliminate errors. The orange, the component attached to the wire do not agree in bit width. So you are connecting one wire to a 3-bit wire. They don't match, so it will give you an orange. Okay, we call it a broken wire. Okay?